Okay, so I'm going to talk to you about some of your homework on section 4.4 and also demonstrate on my calculator. Everybody's calculator may be a little different, but hopefully this will kind of help you to see an example. All right, the first question in your homework 4.4 is just practicing with our calculator, taking the log of 78, for example. Now, whenever it is leaving out this little base area, some of your logs will have a little subscript here and some do not. When you don't see a subscript, it's because it's understood to be a base 10 log, an understood common log, base 10. That's exactly what our calculator will calculate. So if we go over to, say, this calculator and we hit log, notice that on that one, I can't do log and then hit the number. It's what I call kind of a backwards calculator. You have to type in the argument of the log, the 78, and then hit the log button. Notice it is 1.89209, yada, yada. It's actually an irrational number. Non-perfect logs, just like non-perfect square roots, are irrational, so you'll get these long decimals. They'll fill up your calculator display, but it actually keeps going and going. It never repeats, it never terminates. All right, so it's going to tell us something to round to. So do read your directions. It says round to 4 decimal places. So after the decimal, I have 8, 9, 2, 0. So that's the 4th place. The 9 would tell me to round that up. So it rounds up to 1. So my answer will be 1.8921. That's how I would write that in. On this other calculator display, let me see. This one, I can type it in directly. And hit button. Let me see. Where's the log button? Okay, find your log, and then hit 78 equals directly. Lets me do it in the order. I don't know how well you can see that, but it worked. I can hit log, then number equals. So your calculator will be one or the other. Some calculators will be like this one, and you'll have to hit the argument of log 78. Then hit the log to get the answer. On this calculator and many others, it's maybe a half and half split. So it doesn't necessarily have to be a graphing calculator at all, because you know that's not required for this class at all. But I hit log directly, 78 equals, and then it gives me the calculation. So just letting you know that. All right, so that's number 1 on your homework. All right, number 2 is a pH question. It says find the pH, and it's a reading problem. Find the formula for the pH is given, and it tells us pH equals negative log, and we have that button on our calculator, of the hydronium ion concentration, which will be given in your problem. So it tells us then in the reading the pH of a certain agricultural product with hydronium ion concentration is, and it gives us a calculation, 5.4 times 10 to the negative 5. So we plug that in directly, that's what that value is, and then we use the calculator for pH, which is negative log, it's like a negative 1, then log, it's an understood base 10, so that's our regular calculator button pushing. Okay, so say I'm using, let's see, can you see that? So I'm using this calculator. I'll hit my negative or negative 1 if you prefer, then hit log, then parenthesis, and then type it in just like this. Oh, it naturally brings up a parenthesis, you notice there. Oh, maybe that helps. It naturally brought up one parenthesis, so I don't need to put my own parenthesis there. 5.4 times 10 raised to the negative 5. See if I type that in right. You can close your parenthesis or not, probably on that, and it'll be okay. But do you see this 4.2676? It says to the nearest tenth. So again, they've changed the directions on each one. You'll have to watch this. Tenths place here is the 2. So the 6 after it rounds that up to a 3. I should say 4.3 for that answer, the final answer. And that's the pH. All right, next question. Number 3 is kind of an application question of using pH, and it tells us that a wetland, they have these different classifications. A wetland has a pH that is 6.0, between 6.0 and 7.5. and that will be called a rich fin, a particular classification of a wetland, a rich fin between 6 and 7.5. So if you do a pH and it's between 4.0 and 6.0, that's a poor fin. If the pH falls to 3.0 or less, it's a bog. So just kind of, your problem will tell you these different classifications. Then it gives you a pH problem, just like what we just did on number 2. We're going to do it again, and it gives you a different hydronium concentration. If it would have been this problem, we would have taken the 4.3 and then read our directions, and that would have fell within the poor fin. Poor fin is 4.0 to 6.0, it tells us. So if it's the same as number 2, it would have been poor fin. All right, number 3, let me do another example though. It tells us again the pH formula is negative log of this hydronium ion concentration. Then it directly tells you in the reading the hydronium ion concentration to drop into this formula is 3.9 times 10 to the negative 7. So then we type in our calculator the formula. And the formula tells us that we've got negative, so hit our negative button, our log, then we type in, and it did bring up its own parentheses, so I won't need to type that in, 3.9 times 10 raised to the negative 7 equals 6.4-ish, so 6.4, approximately 6.4. Then we look at the directions and we see that 6.0 to 7.5, I believe, a rich fin. Yeah, so that one would be rich, and it just falls in that category. So it's a multiple choice question. I hope you don't just guess your 3 tries there, but give yourself practice on that. All right. So just practicing pH and how that's something very applicable that we know. We hear about pH falling between the 0 and 14, so all your answers in this formula will come out to be something in that range. All right, the next question is using the change of base rule. This is question number 4 in your sample homework. And it says log base 2 of 9. That's how we would read that. Log base 2 of 9. And it says round to 4 decimal places because it's not going to come out perfect. So let me give you a little reminder about what log means. Whenever we're doing a logarithm, this is the base, the little subscripted amount. I won't be able to type this directly on my calculator. My calculator only has a regular base 10 log button. Even if you're using a graphing calculator, that's all you'll see is a regular log, which is understood to be base 10. So we can't directly type this one in this calculator. Also, the ln button is a logarithm based. It's a natural logarithm, and that is base e logs. So whenever you're doing these logarithm problems, you can directly use 2 buttons on your calculator if it's a base 10 log or a base E log, which will have those along, but this one is not. It is a base 2 log. So to do that, some of you all do have a subscript button. Just a few calculators I've seen do, but most do not. So we use this thing called the change of base rule, where we take the log of the argument divided by the log of the base. You can do it with regular log 10s, which we do have a button for, or it also works with the ln. The rule, when you read it in your book, it actually just says any base log. So if you use any base log, as long as you use the same base for top and bottom, you take the ratio of the argument to the base, and it will give you the right answer. So we can do it with our ln button or with our regular log base 10 button, but we want to use something that we have a button for on our calculator, right? So one of these. So notice we'll type in either of your calculators, whatever calculator you're using should be able to do this. I don't know if that light's helping or not. So let's say I do ln. Let's do ln of 9. I want to close that parenthesis because when I hit the ln or the log button, it brings up an opening parenthesis. You will need to close that. Then divided by log of the 2, the base. So that's how we would type that in, equals 3.16, what is that, 99 to 5, yada yada, to 4 places. There's 1, 2, 3, 4. This 9 is in the 4th decimal place. The 2 will not round it up, so I'll write it at 3.1699 for my final answer there. I want you to notice what this log means. Oh, before I do that, let me do it with the other method, with regular common log. So if I type in the log of 9, close your parenthesis, divided by the log base 2 equals, notice it's exactly the same answer, so either one works. Just wanted you to see that happen. What does this mean? The meaning of a logarithm is really a type of exponent. It's kind of written in a different order than an exponent, but it means 2 raised to what power equals 9. So 2 to what power equals 9. To go back and forth between the log form and the exponent form, these two mean the same thing. So when we're solving logs, we're looking for the exponent. That's really what the logarithm is. It's looking for the exponent needed to make this happen. So when you look at log base 2 of 9, it means 2 to what power would give us 9. So 2 to the 2nd would be 4, and 2 to the 3rd would be 8. So still a little shy. 2 to the 4th would be 16, so that's too much. So you know it's somewhere between 3 and 4. And see how that answer makes sense? So if we type in 2 raised to the 3.16, and I'm going to have some rounding arrows, so it won't be exactly right. But you can just see this is so. If we take 2, raise it to the 3.16 power, it's 8.938, so it's off by just a little bit. There'd be a little round off error, but it's pretty close. I could have typed in more decimals to show that, but that's what a log means. So if we're doing like log base 2 to 8, I could have done that one without my calculator because I know 2 to the 3rd power equals 8. So the answer to that would be 3. But to do it on my calculator with this new rule we've just been talking about, I would do log 8 divided by log of 2. This change of base rule, it will always work for any base log. Whether you can do it with or without the calculator matters not. But type in log base 8 or log 8 divided by log 2 or ln 8 divided by ln 2, because it doesn't matter if we do the ln or the log. What matters is you do the ratio of the two numbers here, the argument over the base. Anyway, you can check that out on your calculator, and you should also get 3, because that's what the log means. This base to what power equals that number, the meaning of a log. So again, if I do log base 10 of 100, what do you think that might be? That means 10 to what power is 100. So we know 10 squared, or 10 to the 2nd, is 100. Again, let's do log base 3 of 9. You can do that by hand or on your calculator, but that means 3 to what power is 9? So we know 3 squared is 9. But let's just see if our rule works. If we do log 9 divided by log 3, our rule here that we're practicing. So on our calculator, if I do the log, at either type of log, the log or ln of 9 divided by log 3, notice that's 2. So the calculator would confirm that as well. All right, let's see what's up next. All right, the next question, number 5, is a concept question. Let's see. It says, why is log base 2 of 0 undefined? Log base 2 of 0 is undefined, and why is that? So the meaning of a log, like we were talking about on the last problem, it means 2 to what power is 0. So type in your calculator all that you like. 2 to the 1st is 2, to the 2nd is 4, to the 3rd is 8, and on and on and on. It just keeps getting bigger. Well, what about 2 to the 0? Type in 2 raised to the 0. And that should give us 1. So 2 to the 0 is 1. Okay, I'm getting it. 2, how about to negative numbers, or just type and type. But no way are you going to get 2 raised to power to equal 0. That is going to give you an error reading. Let's just see on our calculator with our rule. Log 0 divided by log 2, that new change of base rule we talked about in the last problem, and see if that confirms it too. Log 0 divided by log really of anything, but we'll do the log 2 it asks, error. You get some sort of error, domain error, or quit, go to. That means something's wrong there. And so the reason is it just does not exist. There is no power 2 can raise to equal 0. All right, I'll come back in on the next video.